Good afternoon, class. My name is Enrique, and my partner's name is Adrian. Today, we will be walking you through a simulation from PhET Interactive Simulations that demonstrate Ohm's law and how it works in an electric circuit.
Ohm's law explains the relationship between voltage, current, and resistance in a circuit. The formula for Ohm's law is V equals I times R, where voltage is the electric potential difference in a circuit. You could think of it as the push from a battery that moves electric charge through the circuit. Current is defined as the amount of charge measured in coulombs, passing a point in a circuit per unit time. Resistance is anything that slows down or opposes the flow of electricity. It is measured in ohms.
Now we will begin with our simulations. Our simulations focus on the equation V equals I times R. In this equation, V stands for voltage, I stands for current, and R stands for resistance. In the simulations, we can change the voltage and the resistance and observe how the current changes. This helps us understand how these three variables are connected and how Ohm's law works in a real circuit. For the first simulation, we kept the resistance constant at 500 ohms. We observed that as the voltage increased, the current also increased, but when the voltage decreases, the current also decreases as well.
For the second simulation, we kept the voltage at a constant of 4.5 volts. We observed that as the resistance increases, the current decreases, but when the resistance decreases, the current increases. Overall, both simulations show the relationship between voltage, current, and resistance described by Ohm's law. In the first simulation, increasing the voltage increased the current when the resistance stayed constant. In the second simulation, increasing the resistance decreased the current when the voltage stayed constant. These results show the current depends directly on voltage and inversely on resistance. As we wrap up our presentation, we also thought about a few questions people in the audience might have. The first question is, how does a battery give voltage? In our simulation, we adjusted the voltage to see how it affected the current in the circuit. In a real circuit, the voltage comes from a battery. A battery creates voltage because of chemical reactions happening inside it. These reactions cause electrons to build up on one side of the battery, which creates a difference in electric potential between the two terminals. When the battery is connected to a circuit, the difference pushes the electrons through the wire. This push is the voltage that drives the current in the circuit, which is exactly what we saw in the simulation when we increase or decrease the voltage.
The second question is, what exactly is resistivity and what types of materials affect resistivity? Resistivity is anything that slows down the flow of an electric current. When electrons move through a material, they collide with impurities inside that material, which makes it harder for the current to flow. Every material has some level of resistivity, except for a superconductor. For example, materials like copper and aluminum have low resistivity, which is why they are commonly used for electrical wires. Other materials like rubber, plastic, or glass have very high resistivity and are called insulators because they prevent electricity from flowing easily. It is also important to understand the difference between resistance and resistivity. Resistivity refers to the natural property of a material itself, while resistance refers to how much a specific object opposes the flow of current. In other words, resistivity is based on the type of material, but resistance depends on both the material and the size of the object, such as its length and thickness. This means that two wires made of the same material can still have different resistances.
To conclude, our simulations help demonstrate how Ohm's law describes the relationship between voltage, current, and resistance in an electric circuit. By changing the voltage and resistance in the simulations, we were able to observe how the current responded. These observations match what Ohm's law predicts, showing that current increases when voltage increases and decreases when resistance increases. Overall, the simulations helped us better understand how these variables interact in real electric circuits and why Ohm's law is such an important principle in physics and electrical engineering. Thank you for your time.
And we would be happy to answer any further questions.